Let's continue talking about conditional trig equations. And by a conditional trig equation, that just means we actually have to solve the equation, as opposed to a trig identity, which is an equation that is always true. So for our first example, let's solve the equation sine of 2x is equal to the square root of 3 over 2. Now notice the difference between this equation and the ones in the last video is notice our input here is a 2x as opposed to just x or alpha. And the way we're going to solve these is very similar to how we were solving them before. So our first step is to just locate where does sine equal root 3 over 2. And well, that happens up here in the first quadrant at the angle pi over 3, and also in the second quadrant at 2 pi over 3. And so we want to describe, all of these angles, and we want to make sure we get the coterminal angles as well. So I'm just going to add 2k pi to each of them. Okay. But now notice our input, since it's a 2x, what we're saying is that 2x is equal to, say this first guy, pi over 3 plus 2k pi. Or we could also have that 2x is equal to our other location, 2 pi over 3 plus 2k pi. And what we need to do next is solve for x. So for both of these equations, we need to solve for x. And the way we're going to do that is, well, we just need to divide both sides by 2, like for this first equation here. So what we have is 2x is equal to pi over 3 plus 2k pi. And so to solve for x, I'm just going to divide both sides by 2. So that's going to give us x is equal to, and notice on the right hand side, both of these terms, pi over 3 and 2k pi, both of them will be divided by 2. So if I take pi over 3 and divide by 2, that's going to give us pi over 6. And then 2k pi divided by 2 is going to give us k pi. So we end up with x is equal to pi over 6 plus k pi. Well, now let's do a similar thing for our second kind of set of solutions. So if 2x is equal to 2 pi over 3 plus 2k pi, let's again solve for x, and we're going to do that by dividing both sides by 2. So what we'll have is x is equal to, and let's see, I have to take 2 pi over 3 and divide that by 2, which is going to give us 2 pi over 6, right? Because basically that 2 just gets absorbed into the denominator. And then plus 2k pi divided by 2 gives us k pi. Oh, and we can reduce this a little bit. 2 pi over 6, that's pi over 3 plus k pi. And so now if we put our solutions together using set notation, what we'll get is the set of x values such that x is equal to pi over 6 plus k pi, or x is equal to pi over 3 plus k pi. And there we go. This is our solution set to our equation. Let's try another example. So example 2. This time we are going to solve cosine of x over 3 is equal to negative 1. And again, first thing is, let's just locate where does cosine equal negative 1. Oh, and that's going to happen over here on the left-hand side of our unit circle, right? This is where cosine is equal to negative 1, and it's the only place where cosine is equal to negative 1. And our angle here is pi. All right, and notice our input here is an x over 3. So when we go to set up our solutions, what we'll have is x over 3 is equal to pi, but let's also include all those coterminal angles, so plus 2k pi. So over here we'll have a plus 2k pi. And what we need to do is solve for x. So for this equation, to solve for x, I'm just going to multiply both sides by 3. So on the left-hand side, we'll end up with x. And on the right-hand side, and I'm going to have to distribute this 3 to both terms. So what we'll get is a 3 pi plus 6k pi. And now finally, let's just write our solution using set notation. So we'll get the set of x values such that x equals 3 pi plus 6k pi. And that would be our solution set. And let's try one more example. So example 3. This time we are going to solve 2 times sine of 3x minus 1 is equal to 0. Now this one's a little bit different because notice we have like this 2 in front and this -1 kind of floating around on the left-hand side. And in order to make this look like an equation we're more familiar with, first thing we're going to do is we're going to solve for the sine function. So we're going to solve for sine of 3x and get that all by itself. So we can do that by maybe adding 1 to both sides. That would give us 2 times sine of 3x is equal to 1. And then I could divide both sides by 2, which would give us sine of 3x is equal to 1/2. And now this looks like an equation that we can solve. So let's first find where does sine equal 1/2? And that's going to occur at pi over 6 in the first quadrant, and then also 5 pi over 6 in the second quadrant. And of course we want all their coterminal angles as well, so we'll consider plus 2k pi for each of them. And now when we set up our equations, notice my input here is a 3x. So we'll have, over here we'll have 3x is equal to pi over 6 plus 2k pi. And then over here we're going to have 3x is equal to 5 pi over 6 plus 2k pi. But again, we need to take each of these equations here and we need to solve for x. So let's start with this first one. So I'm going to, in order to solve for x, I'm going to divide everything by 3. And what we'll get is x is equal to pi over 6 divided by 3. That's going to be a pi over 18. And then plus 2/3 k pi. Okay, so that's what I get from kind of my first set in the first quadrant. And if we look at these angles in the second quadrant, again, we got to solve for x. So I'm just going to divide everything by 3. And what we'll get is x is equal to 5 pi over 18 plus 2/3 k pi. Oh, and there we go. We solved for x in this equation. And so now let's just finish by writing our full solution in set notation. So we'll get the set of x values such that x equals pi over 18 plus 2/3 k pi, or x is equal to 5 pi over 18 plus 2/3 k pi. And there we go. This describes all of the solutions to our equation.